Okay, in this lecture, let's talk about the inferences of proportions. We have talked a lot about the inferences on means, how to calculate the confidence interval for the mean, how to conduct a hypothesis test for the mean. Mean is the most commonly used way to summarize quantitative data. If you want to summarize the categorical data, the most widely used summary is the proportion. For example, if you want to know, we have actually used this example before, the proportion of people in North Carolina who's in favor of a tax increase. So the population parameter we are interested in knowing is the population proportion of North Carolina residents who are in favor of tax increase, right? The sample proportion would be if we collect the sample, say we take the students in this class as a sample. Let's forget about whether this sample is representative or not for the moment. So the sample proportion would be the number of people who's voting for yes. I think there would be two of us. We did this before. The word was upside down. The total number is, let's say, 80. So the number of yes divided by the total number is the sample proportion. We use P with a hat to denote the sample proportion. We use this P to denote the population proportion. If you could still recall, like what we have done for the mean. So the first thing we do is to try to find out the sampling distribution of the sample means, right? If you guys still remember what is sampling distribution, that is, if you collect the sample and then you calculate the sample mean, you go ahead to collect another sample of the same sample size, you can calculate another sample mean. All those sample means putting together will form a distribution that is called the sampling distribution of the sample mean. Same idea here, we can find out the sampling distribution of the sample proportion. The reason we want to use sampling distribution is it will provide us a predictable pattern of the sampling variability, which lays the foundation for inference. It will tell you sample proportion that you got, it's something reasonable or it's something not ordinary, which allows you to estimate the margin of error. That is the foundation to build a confidence interval, right? It will also allows you to use this probability model to determine whether a particular, like we have mentioned, a particular guess about the population parameter is reasonable or not using the hypothesis test. So let's talk about it. What is the sampling distribution of sample proportion? That is, if you collect the sample from the population and you calculate its proportion. You go ahead to collect another sample and calculate a second proportion. If you repeat this procedure, say for 1,000 times, you will have 1,000 sample proportions. All those proportions will form a sampling distribution. That's called the sampling distribution of the sample proportions. So what do you think this distribution would be like? Remember when we talked about distribution, we are interested in three things: the shape, the center, and the standard deviation. So let's talk about those three one by one. The shape of this distribution will be normal or at least bell-shaped if some conditions are met. So the conditions that we need to satisfy is it's normal when your sample size is large. And the rule of thumb for how large is being large enough is the n times p, the sample size times the proportion is greater than 10, and n times 1 minus p is greater or equal to 10. This is the first characteristic, the shape of the sampling distribution. The second characteristic, the center, is the true value of the population proportion. So that's easy to understand, right? The center of the sampling distribution of the sample proportions will be the true population proportion. The standard deviation would be p times 1 minus p over n. Do you know when will this be largest? So if you want to find the when will this value be largest, you will need to find, we want to find the value p, which makes this p times 1 minus p largest. If you do the derivative of it, so this dp minus p squared dp, this is 1 minus 2p, we set them to 0, we will have p equals 1/2. This is when this is largest. So when p equals 1/2, the standard deviation of the sample proportion will be largest. If this derivative here is a little bit difficult for you, you could also draw the graph. So if you draw this p minus p times 1 over p, and it will be something like this. And I'm sorry, it will be the other way around. It will be something like this. And then here is 1/2. So this is when your standard deviation is largest. Now, having said that, let's continue to construct the confidence interval. So in order to construct the confidence interval, we use the test statistic, right? This is the test statistic plus or minus the margin of error. Here, this is the margin of error. If you guys still remember, the margin of error is the numerical indication of a distance, maybe from the true parameter. So this is the margin of error of the proportion, where Z stands for the standard normal distribution because the sampling distribution is normal, so we use this Z here. The conditions for this interval to be valid are two. First, it has to be a random sample. Second, the sample must be large enough. How large is large enough? We use this n times p hat greater or equal to 10 and n times 1 minus p hat greater or equal to 10. So let's take a look at the example on how to find this confidence interval. If you haven't read it, so you could pause the video here and come back to watch it. So this is an example of how to calculate the confidence interval for a proportion. So the first thing, let's check if the conditions are met. So from the question, we know that this is a random sample. The second condition, NP hat, is 100, your sample size, times your proportion, sample proportion 0.78. This is bigger than 10. And your n times 1 minus p hat is also bigger than 10. So our conditions are met. We could go ahead to calculate our confidence interval. Let's plug in the numbers into this formula here. So p hat 0.78 plus minus the z value. It's a 95% confidence interval. The z value is 1.96. We have talked about how we could find this value for many times, so I'm going to skip the step here. So this is p hat 1 minus p hat divided by the sample size 100. It's 0.699 to 0.861. So this is the confidence interval for the proportion. And we've also talked about how to interpret the confidence interval for many times. So we are 95% confident that 69.9% to 68.1% of all undergraduate students at this large university have used library. Okay, I will stop it here. Hello.